Hello and welcome. Today we will discuss effect of cooking on food. The main objective of today's lecture are cooking of food and its origin, different methods of cooking, changes during the cooking of food, effect of cooking on different constituents of food, cooking, its merits and demerits. Let us start with the introduction. Cooking was invented over 2.3 million years ago, whilst others argue it is a more recent concept, being invented only 40,000 years ago. Food is being cooked since the times of the early man, when he accidentally discovered that cooked meat tastes much better than raw meat. Cooking is the process of producing safe and edible food by preparing and combining ingredients, and in most cases by applying heat. Cooking is the means of processing food, without which many foods would be unfit for human consumption. Dear students, let's know why we cook food. Though the main objective is to make the food edible, yet there are other reasons for cooking, such as to make the food attractive and palatable. Cooking makes the food look attractive and also renders it more tasteful than the uncooked food. To make the food digestible, cooking makes the food soft and tender, thus makes it easy and quick to digest. For example, after cooking carbohydrates, rich foods, they become easier to digest and to a certain extent. To introduce variety in meals, variety can be brought about in meals easily by using different methods of cooking. For example, one single foodstuff like potato can be cooked by using different methods into a number of dishes and thus add variety to meals. To enhance availability of some nutrients, nutrients are released in the cooking that would otherwise be unavailable. For example, phytic acid is a naturally occurring chemical in grains that can partially block the availability of grain minerals, including iron and zinc. The processing and cooking of grains lowers their phytic acid content, often more than 50%. To destroy microorganisms, cooking of foods destroy the microorganisms present in them to a large extent, thus making it safe for consumption. Raw milk may have microorganisms responsible for causing tuberculosis and typhoid, and such milk, if consumed, can be harmful. Meat, especially pork, contain eggs of worms Trichinella spiralis, which can cause infestation in the body. Fortunately, these microorganisms are destroyed by usual cooking procedures, hence making the food safe. Most cooking methods, if performed properly, will heat foods to over 70 degrees centigrade. So, applying such a temperature for a calculated time period will prevent many foodborne illness that would otherwise manifest if the raw food is eaten. Campylobacter, Salmonella and Listeria monocytogenes are the three of the most common food poisoning bacteria, and together are reported to affect 380,000 European Union citizens each year. Increasing consumption of food or edibility. Cooking can cause changes in the color, flavor and texture of foods that allow us to create foods that we derive pleasure from eating. Cooking improves the texture and makes the food chewable. Concentrate nutrients. This may be due to removal of moisture or using combination of foods or due to cooking procedures. For example, sweets. Thus, cooking of food is very important as it increases digestibility, appeals to palate and destroys microorganisms. Now, we will discuss different types of methods used to cook food. The fundamental types of cooking from which cooking methods stem across Europe and indeed the world are listed as under. First, we will discuss frying. Frying is the cooking of food in oil or fat. Usually, fried foods have a characteristic crisp texture. This is because oils and fats can reach higher cooking temperatures than water. Common types of foods that are fried include battered or breaded fish or vegetables, chips and donuts. Now, what are different types of frying? First, we will discuss about stir frying. A frying pan is used to cook foods at a very high temperature in a thin layer of fat. The food is fried very quickly and stirred continuously to prevent the food from burning. Next is deep frying. Large deep pan or deep fat fryer is half filled with fat and heated. Food is immersed in the fat for a few minutes and then removed. The next is shallow frying. A large shallow pan is filled with a layer of fat deep enough to cover 1/3 of each piece of food. As with deep frying, the fat is heated prior to food being added to the pan. After a few minutes, the food is removed from the pan and drained. Another method of cooking is baking. Baking is the process of cooking food in the dry heat of an oven. During baking, moisture within the food is converted to steam, which combines with the dry heat of the oven to cook the food. Common types of food that are baked include bread, cakes, and pastries. Now we will discuss boiling. Boiling is the cooking of food in a liquid, for example water and milk, which is at boiling point. Common types of food that are boiled include vegetables, rice, eggs, potatoes, and beetroot. Now next is simmering. Simmering is also similar to boiling, except that the food is cooked in liquid which is held below boiling point. The simmering point of most liquids is between 85 to 95 degrees centigrade and compared to boiling is gentler and slower method of cooking. Common types of food that are simmered include vegetables, soaps and sauce. Now next is grilling. Grilling is the cooking of food using a direct and dry heat. Common types of food that are grilled include fish, meat, vegetables and bread. Now next is steaming. Steaming is the cooking of food by steam. Steaming is done in two ways, that is direct steaming and indirect steaming. First we will discuss direct steaming. In this method the food comes in direct contact with the steam. Direct steaming can be done in an ordinary steamer or in an improvised steamer. For example, steaming of cut vegetables or sprouted pulses, fish, idli, dhalka, etc. Indirect steaming. In this method, the food does not come in direct contact with the steam, but is cooked by the heat of the steam surrounding the container containing the food material. Examples of indirect steaming are steaming of puddings like custards, etc. Now next is roasting. Roasting is the cooking of food using dry heat. This may include cooking in an oven or over an open flame. Normally the food is placed in a roasting pan or rotated on a spit to ensure an even application of heat. Typically foods that are cooked by roasting include meat and vegetables. Now next is canning. Heating of food in hermetically sealed containers is known as canning. Nicolas Appert, a French confectioner, was the first to demonstrate canning of foods. Canning requires a medium for heat transfer, for example, oil or water. Time and temperature combination during canning is of prime importance. More severe heat treatment or heating for prolonged time may have negative impact on product quality. Now we will talk about merits and demerits of cooking. First we will discuss about merits. The first is changes in flavor. Flavors of the food during the cooking are produced by caramelization process. This type of process is characteristic of many food products such as dark beer, coffee, confectionery, and peanuts. The caramelization reaction occurs when foods containing a high concentration of carbohydrates are cooked at high temperatures using dry heat. For example, roasting peanuts. Caramelization generates hundreds of flavor compounds. One of the most important flavor compound produced is diacetyl. Other important flavor compounds produced during the caramelization reaction include the furans, hydroxymethylfurfural and hydroxyacetylfuran, and maltol from disaccharides and hydroxymaltol from monosaccharides, which together contribute to give sweet, slightly burnt flavor. The flavors generated during caramelization can vary substantially depending on the type of carbohydrate undergoing the reaction. Any food that contain high concentration of carbohydrates, for example, beer, coffee, peanuts, and confectionery undergoes caramelization during roasting, grilling, baking, and frying. Now next we will discuss Maillard reaction. The Maillard reaction is essentially a chemical reaction between an amino acid and sugar such as glucose, fructose, or lactose. The complex pathways of chemical reactions not only generate important flavor compounds, but they also produce brown color compounds known as malanoids. Malanoids give many foods their characteristic coloring, for example, coffee, bread, and meat. For example, the Maillard reaction is responsible for producing many sulfur-containing compounds, which contribute to savory, meaty flavor characteristic of cooked meat. Next, we will discuss starch degradation. The polysaccharide starch is present in all plant seeds and tubers, which means it can be found in many foods such as pasta, rice, bread, potatoes, and oats. When foods containing starch are cooked, the heat breaks the glycosidic bond linking the glucose units together and effectively break up the polysaccharides to release the glucose monosaccharides. Next, we will discuss changes in color. In this, we will discuss caramelization. The color of cooked food has great impact on its acceptance of food. Different physicochemical reactions occurring during the cooking of food are responsible for generation of typical color. Besides this, various factors like temperature of cooking, time of cooking, ingredients used, intrinsic and extrinsic factors of food play a vital role in the development of color. However, the main processes responsible for generation of color in most of the foods are discussed here. Caramelization reaction, which not only generates important flavor compounds but also imparts color in most of foods by process of browning. During the caramelization reaction, molecules known as caramels, that is caramelins, caramellins, and caramellins are generated, and it is these compounds that are responsible for characteristic brown color of caramelized foods. As with flavor generation, during the caramelization reaction, the color of caramel also varies depending on the type of carbohydrate undergoing the reaction. Next, we will discuss changes in texture. In this, we will discuss protein denaturation. Many foods contain proteins such as meat, fish, eggs, vegetables, nuts, and pulses. Proteins are large molecules composed of strands of amino acids, which are linked together in a specific sequence by formation of peptide bonds. During cooking, the heat causes the proteins to vibrate violently, which results in the breakage of weak hydrogen bonds holding the amino acid strands in place. Ultimately, the protein unravels to retake its initial form of amino acid strands. The denaturation of protein molecules in the foods usually causes a substantial change to the texture of food. For example, egg white is composed of two key proteins, Overtransferrin and ovalbumin. As the egg white is heated, overtransferrin begins to denature, first entangling and forming new bonds with the ovalbumin. As the temperature increases, ovalbumin then starts to denature, unraveling and forming new bonds with the overtransferrin until denaturation and rearrangement of the protein molecules are complete. In this case, the rearrangement of protein molecules results in the change of runny fluid texture to a rigid firm texture. Conversely, protein denaturation can also cause the formation of softer textures. For example, the protein collagen, which is the major component of connective tissue in meat, has a tough and chewy texture. However, during cooking, the weak hydrogen bonds are broken and the protein begins to decompose and react with water molecules to form gelatin. This tenderizes the meat, giving it a softer and more palatable texture. Next, we will discuss polysaccharide gelatinization. Foods containing the polysaccharide starch such as potatoes, wheat, rice, pasta, corn flour and rice flour are often used to create and or thicken sauces. This is because the cooking of these foods causes a process known as starch gelatinization. When cooked in water, the starch granules absorb water and swell. Now we will like to discuss demerits. First, we will discuss loss of pigments. The main foods containing pigments and therefore likely to be prone to losing pigmentation during cooking are fruits and vegetables. Chlorophyll, a fat-soluble pigment, may leach from fruits and vegetables if they are cooked in a medium containing fat. For example, stir frying. As well as the cooking medium, the chlorophyll pigment may be affected by the length of cooking. Long cooking methods with a fatty cooking medium will therefore have a detrimental effect on concentration and intensity of the chlorophyll pigment that remains in fruits and vegetables during cooking. Similar to chlorophyll, carotenoids are also fat-soluble colorants, which mean cooking methods involving the use of fat may also cause leaching of these pigments. Cooking methods which expose fruits and vegetables containing carotenoids to the atmosphere for a long periods of time, for example, boiling without a lid, will therefore cause the depletion of pigment resulting in paler colored food. Anthocyanin and anthocyanins, which are water-soluble pigments and thus may leach into cooking water during soaking or prolonged heating. Cooking methods avoiding water such as stir frying will thus minimize the loss of these pigments during heating. Food types that may undergo pigmental losses are fruits and vegetables. The cooking methods that may result in pigmental loss are boiling, frying, grilling, steaming and roasting. Next, we will discuss loss of vitamins. The difference in vitamin solubility means that the method by which foods are cooked has a substantial influence on the final vitamin content. Due to their tendency to disperse in water, these vitamins in particular are heavily affected by cooking processes that involve immersing food in water for longer periods of time. For example, boiling. In contrast, fat-soluble vitamins tend to be lost during cooking processes where foods are cooked in fat. For example, frying or when fat is lost from the product. For example, grilling. Cooking medium and the length of heating can also affect the vitamin content of foods. Both fat-soluble and water-soluble vitamins are susceptible to heat, with the latter being particularly sensitive. Short cooking methods such as stir frying and blanching help to reduce the heat degradation of vitamins compared to longer cooking methods such as roasting. Next, we will discuss about the minerals. As such, there is no loss of minerals in normal cooking procedures. If cooking water is discarded, a small fraction of water-soluble minerals may be lost. Heating itself does not affect mineral levels but are usually leached if cooked in boiling water. Minerals tend to have higher heat stability and are less affected by cooking methods which involve heating foods for longer periods of time. Food types that may result in loss of minerals. Foods containing minerals, for example, meat and vegetables. The cooking method that may result in the loss of minerals is boiling. Next, we will discuss about fats and oils. Ordinary cooking has no effect on fat, but prolonged heating, as in the case of frying, for long periods thickens and darkens the fat. A part of essential fatty acids present in fat are destroyed and toxic polymerized products are formed. Let us know about following changes that occur during cooking of food. In this section, we will discuss generation of undesirable and desirable compounds. First, we will like to discuss undesirable compounds. Over recent years, it has become evident that cooking of foods can lead to generation of undesirable compounds. The generation of potential carcinogenic compounds has received particular attention due to the serious nature of their possible consequences. Perhaps the most well-known of these compounds are nitrosamines. During cooking, nitrosamines are produced from nitrites and secondary amines. Several other compounds are considered as carcinogenic, such as acrylamide and heterocyclic amines, which are both formed as a result of Maillard reaction, as well as furan, polycyclic aromatic hydrocarbons and chloropropionol or esters. Polycyclic aromatic hydrocarbons are produced when any incomplete combustion occurs from grilling, roasting and frying, but also smoking and drying dependent on fat content. Most PAHs are not carcinogenic, although a few are, such as pyrene and benzopyrene. Chloropropanols or esters have also been linked with the thermal treatment of the processed food products. Next, we will like to discuss about desirable compounds. Despite the fact that cooking can cause the generation of undesirable compounds, research has shown that cooking can also increase the formation of favorable molecules and the bioavailability of some antioxidants such as lycopene. Unlike heterocyclic amines and acrylamide, antioxidants are known to be beneficial to human health. Antioxidants are also generated during the Maillard reaction. Food types like meats, biscuits, bread, potatoes cooked by the frying, baking, grilling and roasting generate desirable compounds. This was all about today's lecture. Hope you understood it well. Thank you very much.